Hey Algebra 1, here are the notes for 7.5 regarding graphing systems of inequalities. So we're going to solve the systems of inequalities by graphing. The first thing you should remember about these, and maybe a note that I would put at the top of my page if I were you, is I would remind myself when I have a dashed or dotted line versus when I have a solid line. When I have an or equal to symbol under my inequality, that is going to be a full solid line. When it is only the inequality sign less than or greater than, it's going to be dashed. So looking at this first problem, we have y is less than x plus 1. Well, if I were graphing this, I'd go up to 1, and then of course I would go up 1 over 1 for my slope. And I noticed just by looking at this right away that it doesn't have that little that little symbol underneath. So this is going to be a dashed line. So I'm just going to dash this through. And I gave you two methods in class. Now, if you weren't in class, I'm going to give you both methods. But I'm only going to show you the first method once. I think it gets a little bit messy, so I don't personally like it very much. So once I've graphed my line, I have to shade one side or the other. So if I need to shade one side, I need to check a point with this one. Let's check 0, 0. When I plug 0, 0 in here, I get 0 is less than 0 plus 1, or 0 is less than 1. So is that a true statement that 0 is less than 1? Yes. So I know that this side, because 0, 0 works, that means everything on this side of the line works. So I'm just going to shade this side. And you'll notice I'm doing it very lightly, and I'm just doing it with a few lines. You'll see why in a minute. Now when I graph my second line, I notice I start at positive 3, because it's the number not attached to x. And then I'm going to go down 2 over 1. Down 2 over 1, down 2 over 1. I keep going just to be consistent. I am going to grab a ruler here real quick, or something that's a straight edge, because I don't want my lines to be messy. I notice this one is a less than or equal to symbol. It's a little bit different way because that's how I typed it. But I know that that means it's a solid line. So I'm going to create my line here, make sure it's nice and solid. And then I'm going to decide which side of the line I have to shade. I see 0, 0's on the left side, so when I plug that in, I get 0 is less than or equal to, this cancels, and I get 3. This is a true statement, so 0, 0 works, meaning I'm going to shade everything on the left-hand side of this line. Now, right now, I'm ignoring this other line and this other shading I did, and this one, notice I'm just going to do up and down marks for this line. Now, why did I do this? Because ultimately, the answer for this problem is where the two sections interlap. It's where they come together. So I've got a section over here that's shaded once. I've got a section over here that's shaded once. But ultimately, the only section that includes both is this lower section. So that's the section that I'm going to color in more completely to indicate that that is where it's true. That is where my values lie. So this is the first method. The second method is a little bit less messy in my opinion, and I prefer it. However, if this method works for you, the only thing that I ask is that you make sure I know which section is darker than the others. If I can't tell, I will be unable to grade it and I will mark it wrong. So let's jump down. I'm actually going to go down and then I'm going to go over, because this one I think is easier to show with the second method. So I'm going to graph my first line. I notice they are both solid right away, so that's something that can help me. Go down to -3, and then I notice my slope is positive 2 over 1. I'm going to connect these with my straight edge. And then instead of shading one side or the other, I'm still going to check. So let's check 0, 0. When I plug it in, I get 0 greater than or equal to -3. That's a true statement, so I'm going to shade this side of the graph, but not right away. Instead, I'm going to indicate with some little arrows on either end of my line that that is the side I would shade. Now I go on to my next line. I'll come back, don't worry. I'm going to go up to 2, and then I'm going to say up 2 over 1, up 2 over 1. Notice these two lines are parallel, so they should go right alongside each other. And I'm going to do the same thing with this one. I'm going to ignore this other line. I'm going to test a value. I notice 0, 0 is on the right side of my line this time. So when I plug it in, I get 0 is less than or equal to positive 2. That's a true statement, so I'm going to shade the right side of my line. Now, why did I do it with arrows instead? Well, this time, instead of shading everything over here and then shading everything over here and trying to recognize that the middle section is where everything comes together, now I can just look to my arrows and say, oh, the only section where both arrows point to is right in the middle of these lines. So again, both of these methods work, but I do tend to think that this one is a little bit less messy. It's a little easier to see your final answer. All right, let's see another example. This one, unless you're going to use the x coordinate and the y coordinate, the two intercepts, you have to solve these both first for y. I personally think that's a little bit easier, so it's what I'm going to do. I'm going to move that 2x to the other side, and then I'm going to solve this one down here and say y is less than negative 2x minus 2. And then I'm going to graph both of these. I'm not going to show you how I graph both of these each time. We are well past our graphing units, but if you have problems with graphing, don't hesitate to come see me. We can keep working through that until you're confident with it. I'm not using a straight edge, but I am just going up. My slope is up 2 over 2 each time. So there's my dotted line. I test 0, 0. I say 0 is greater than positive 1. That's not true. So these are going to go away from 0, 0. All right, I'm going to put that other line on here now. I go down 2, and then I notice my slope down 2 over 1. It's also a dashed line. So I've got another set of parallel lines here. But when I check their arrows, I notice they both go out. So these two actually don't intersect anywhere. And there's nowhere that they're both true. So this one is actually a no solution problem. These do happen on occasion, and we don't have to write no solution because when we say solve by graphing, the graph itself is actually our solution here. All right, let's look at one more. Again, these ones, unless you are going to solve by the intercept method, you first have to solve them for y. I'm going to do that down below the graph, actually, where it's easier to see. So number 1 becomes y less than or equal to negative 1/2 x plus 1. Number 2 becomes y greater than or equal to negative 3/2 x plus 1. And 3 doesn't change at all because it's already solved for y. All right, let's graph these. One starts at 1. That one is a solid line. When I test 0, 0, I see that it's true, so I'm going to point towards 0, 0. I would be shading this side of the graph. Let's graph that second one. This one starts at 1, 1, goes down 3 over 2, down 3 over 2. That one's also solid line. When I test 0, 0, which is on the left side of that line, it's 0 is greater than 1. That is not true, so I point away from 0, 0. And then my last line is just a y greater than -1. I know that a y equals line is always a straight line, so this one's going to go through -1. It's going to be a dashed line. I know that first one looks like it's going to be solid. I usually just go a little bit beyond so you can see where that is. Dashed lines are a little hard to see. And numbers that are greater than -1 are going to be above it, so we're going to go up. And when I look at all of these arrows, the tiny little area where they meet is this triangle. So just because I have 3 lines doesn't mean I can't do the problem. It doesn't change any of my actual steps. It just adds one more line to be aware of. So don't let it overwhelm you. Don't let it get the best of you. That is all there is for 7.5. Please let me know if you have any questions.